So let's solve a system of equations by echelon and reduced echelon form. So we have the system of linear equations. We must convert it into its augmented matrix. So what you'll do in an augmented matrix, you'll separate, put a slight separation using these triple dots here. On the right hand side, you'll put the constants in column form, and over here, you'll put the coefficients in their respective columns. So this is the x1 column, this is the x2 column, and this is the x3 column, the coefficients of x1, the coefficients of x2, and the coefficients of x3, and this is the constant column. And this is in its augmented matrix. And now basically you'll have to do row operations to convert this into its echelon form. We've discussed the requirements for a matrix to be in echelon form. So you must first have the leading zeros must increase as the number of rows increases. So there must be zeros here and here. So how will you do that? So basically you'll form row operations by subtracting 2 R1 from R2. This, just to be clarified, this is R1, this is R2, this is R3. This entire row is R1, this entire row is R2, and this entire row is R3. So subtracting 2R1 from R2, you get this row. And then you subtract 5R1 from R3 to get this. And so now you have two zeros here instead of 2 and 5. So the next step now is you must have the leading entry in each row must be 1. So this 7 here should be a 1. So you'll convert this by doing another row operation. So you'll subtract R3 from R2 to get this matrix. Now, what you must do here is you must convert this 6 into a 0, as the number of leading zeros must increase. Since there's one zero leading zero in row 2, there must be 2 leading zeros in row 3. So what you'll do here is you'll perform another row operation. You'll subtract 6R2 from R3 to get this. And now you must remember, as I mentioned earlier, the leading entry must be 1. So this 19 must become a 1. What you'll do here is you'll perform another row operation. You'll divide the entire row 3 by 19 to get this. Now this matrix is in its echelon form, not its reduced echelon form. It is in its echelon form. You can solve the system of linear equations just by using this here. And how you'll do that is you'll write them down. You'll write the rows down in their equation forms. So this row 1 becomes this equation, row 2 becomes this equation, and row 3 becomes this equation. So the value of x3 is explicitly 24 by 19, as we've seen from the echelon form. You'll put the value of x3 in this equation 2 here to find the value of x2, and by solving it, you get the value of x2 as minus 9 by 19. You'll use the value of x2 and x3 and you'll put them in equation 1. And when you put them in equation 1, you get the value of x1 as 11 by 19. So the x3 is 24 by 19, x2 is minus 9 by 19, and x3 is 24 by 19, x2 is minus 9 by 19, and x1 is 11 by 19. Now, let's solve this by turning the echelon form into its reduced echelon form. In a reduced echelon form, you must remember, as I've mentioned earlier before, is that the leading entry in each row must also be the only non-zero entry in its respective column. So this one here is clearly the only non-zero entry in its column. But this one here is not the only non-zero entry in its column. -2 is also in its column. And and every element in the last column is a non-zero entry. So we must convert this. So what we'll do here is we'll perform another row operation by adding R1 and 2R2, you get this matrix. So now you see this leading entry of the second row is the only non-zero entry in its respective column. Similarly, we'll perform these row operations to convert this matrix into this matrix. Now this leading entry 1 here in the third row is the only non-zero entry in its column. Now each leading entry is the only non-zero entry in its respective column, and this is the reduced echelon form. And simply you can see that x1 is equal to 11 by 9, x2 is minus 9 by 19, and x3 is 24 by 19, and so you've solved the equation.